Hi, this is Charles Sanderson. I'd like to do a couple of demos of how Aspen Custom Modeler works, and hopefully that'll be useful to people starting out using the tool. So first off, to open Aspen Custom Modeler the first time, it sits in the Aspen Plus folder as Aspen Custom Modeler. In versions before, I think it's version 9, it sits as its own item as Aspen Custom Modeler under the Aspen Engineering Suite, but since version 9 they've put it underneath Aspen Plus. So you open it up. In this first demo, I'm just going to give you a quick overview of the sections of the model and the user interface and how it works. So basically, it's an old school piece of Windows software. You've got drop-down menus that do various things for you. You've got a few buttons that are shortcuts to doing things, and then you've got three primary windows. A simulation messages window that contains the debug messages and the sort of feedback from the system saying I've saved the file or you've loaded a snapshot, that sort of information. You have the flowsheet window that contains the model of the process that you're modeling, so the unit operations and the streams connecting those unit operations. And then over here you have the Explorer window, which is the one I'm going to focus on primarily. This is made up of two parts. You've got a top half, which is sort of telling you the folder that you're in, and the lower half, which is the contents of that folder. So at the simulation level, the information down here is basically a repeat of the items in the menu. The first one is the component lists. That tells you what components you're using in your flowsheet. So your streams are made up of a number of components, say water, ethanol, and sugar. And you tell the model what components it's using there in the component lists. And you can have multiple component lists, so you can have different sets of components in different parts of your model if you want to. The global folders contains values that are true across the whole of the flow sheet. So that includes things like fundamental constants, the value of pi, the value of gravitational constant on Earth, those sort of things you'd put into the globals level. I also use it to put in things that are going to be true across the whole flow sheet. So things like the temperature of the cooling water, or the ambient temperature, or the relative humidity of the air, those sort of things you can pop into the globals level. The flowsheet level contains a listing of all the items on the flowsheet, plus any information that is specific to the whole flowsheet. So, for example, if you put in equations for the economics of the process, you'd put those into the flowsheet level. If you build summary graphs or summary tables of data, those would be probably flowsheet level information, pieces of information. And this will make more sense once we get into some examples later. The other two major areas to look at are the custom modeling and the libraries. I'll look at the libraries first. These both have the same structure beneath them. So each of the libraries has the same basic structure as the custom modeling. And really the difference is these are ones that have been pre-written by somebody else, and these are ones that are specific to this particular text file that you've opened up, this particular model of ACM. Within the library, you've got a number of components. As you build the model out, you start off by declaring some variables, and this is probably the most useful table for first-time users to get a little bit familiar with. So inside of the libraries, the modeler library, which is the generic component that comes from Aspen when you license the software, it defines a whole series of variables for things like, I don't know, the mass-based concentration. And within that variable declaration, you give it a name, you give it a default value, a lower and an upper bound. In other words, the mass concentration has to be non-negative, and it's not going to be more than 10 to the 5 or 5 times 10 to the 5. And then you can also optionally declare a physical quantity associated with that variable, and that basically gives it units of measurement. So in this case, it would be kilograms per meter cubed by default. And this is a comment just telling you that's its default value. So this tells you the types of variables that Aspen has anticipated you might be using. You can, of course, declare your own variable types. Once you declare the variable types, you're going to declare a port. A port declares how you interconnect streams. So what happens at basically between the start and the end of a stream. So in this case, what they've done is they've said it's going to have a molar flow rate, a mole fraction, a temperature of pressure, and a molar enthalpy. So you declare a variable name, and you tell it what type of variable type it's going to be. and then you can give it a description, and you can give it a default value, you can give it a default specification, and various other bits and pieces. Once you've declared your ports, you're then going to start declaring your streams. The streams are similar in that you come in and you declare an inlet port and an outlet port, and then you have the option of throwing in more variables and equations to declare how that stream works. And then finally, once you've got the connections between things, you've got the streams to connect them with, you come in and declare some models. Looks like this is a dynamic valve model, and again you come in, you declare your variables, your ports, you can change your default conditions, and then you start putting in equations. This is a fairly complex model, so I won't go into detail on that one. So that's the basic structure of ACM. So you have the libraries and then your own custom version of those libraries, and so you can see that's basically the same structure. Once you've built your models and you've connected your ports, I didn't talk about parameter types, but in the same way that you have variables, which would be things like mass flow, you can have parameters which might be the valve is open or closed, or there are 1, 2, or 3 phases to be considered in this model. So you declare that as a parameter type, which would be number of phases, and then the acceptable values might be 1, 2, 3. Procedures are interfaces into bits of Fortran or C that you choose to write. Scripts are basically Visual Basic macros that you can run to do a series of steps. And then tasks are, if you're doing a dynamic simulation, a task allows you to do things like, say, run for 5 hours, wait until the tank is full, then take this action. So that would be the tasks. The final 4 elements here in the Explorer window really I rarely use. These are sort of alternative options of getting at some of the values up here, but you've got your simulation options where you tell it what nonlinear solver to use, what integrator to use, all those sort of things. The snapshots are a recording of every value available in the flow sheet, so that later on you can come back and solve again at that condition. The run options tell you things like what mode of operation you're in, which you could also do here, how frequently the dynamic simulation is going to communicate, how long it's going to run, that sort of thing. And homotopy is a tool that lets you step from one point to another. Analysis tools I don't think I've ever used. I think that's an interface into the estimation and optimization. Yes, it is. Same as up here. So this lets you, estimation is where you say, I've got some plant data, now vary these parameters in the model to fit that data. So it might be you have reaction kinetics and you're fitting the Arrhenius parameters. Optimization, you'd be saying, I've put in the economic model, now minimize the cost to produce the product. You can change units of measurement at a global level, and you can interface into some other tools. Okay, so that's the basics. Hopefully that's useful, and I'll do a couple more simulations shortly.